Yes, you guys heard about kind of the larger picture this morning. Where are we? Where are we going? What needs to be done? And I really like to build things. So I'm going to focus in on very micro level on one project that we've been doing that is kind of an example of the kind of work that needs to be done everywhere. Stormwater is a ubiquitous problem. It's a huge problem in the Schuylkill and throughout the state, especially in the southeast. Philly Water has been a real leader in stormwater, green stormwater infrastructure. So we've been trying to apply new innovative concepts to stormwater management and provide demonstrations for other municipalities as they start to implement their MS4 projects. So this is one project out of the many that are happening and will be happening, and it's supposed to be used as a demonstration for other projects to take place. So I'm hoping that you'll all learn from some of our concerns and our issues throughout this project, and you know, not make the same errors that we made, and then also learn from our successes. So I don't know if I might have to be on this side to advance the slides. Maybe I'll just come back here. So first of all, this project takes place in the Perkiomen watershed. You can see the Perkiomen is pretty much the northwest half of Montgomery County, and the conservation district is a service for Montgomery County. We work with DEP and we work with the county as well, the county government, but we know that watersheds cross county boundaries. We know that they don't care about municipal boundaries, so we try to be as collaborative as possible in our projects. So focusing on the Perkiomen Creek, it's one of the, it has the most unimpaired waterways of any part of my county that I'm focused on. Its designated use is simply a warm water fishery. That means, as John was talking about earlier, we don't have a ton of protections for it. It is an important drinking water resource on the north end of the county. We have a Green Lane reservoir that's owned by Aqua. We have a lot of surface and groundwater withdrawals for drinking water treatment. So this is really important for hundreds of communities. We have impaired reaches and impaired streams. In the newest 2016 Integrated Water Quality Report, we have new sections that have been deemed impaired. So this is one of those watersheds that maybe has a B grade, maybe pushing a B+, but it's getting worse, and we want to stop it all we can. So these impairments are due to urban runoff, increased flows of stormwater, with increased development. We have pretty high development rates. We have a lot of sediment going into our watersheds. We have nutrients and also thermal impacts. So a lot of these things can be fixed with better stormwater management. So Perkiomen Township is right in the middle of the watershed, and I'm sorry, I can't, I'm gonna have to be traveling back and forth. They contacted me initially to start this project. They were concerned about a wet area on their property. They knew they had to do more to control stormwater, but one of their main goals was to make this wet area of their property more usable and potentially more mowable for their public works crew. So I knew some education was going to have to take place. There is a Pico right-of-way right along their property line, and you can see there were plenty of grasses that were coming over and filling in this wet area where they couldn't mow. So for them, it was an aesthetic problem. They were worried about invasive species, and they were also worried about a potential liability problem in the winter when all of this wet area would become ice. It's right next to a playground. In the summer, they were worried about mosquitoes. So the township had all these concerns. They saw me do a rain garden talk and said, hey, let's put in a rain garden here. My first thought was, I don't know if a rain garden's gonna fix this huge issue. You've got all this water coming down. Let's look at where the water's coming from and try to stop it before it ever gets to this point in your property, this low point. So here's an overview, an aerial of the property. You can see the Perkiomen Creek is right here. This is the main branch. It's about 200 feet wide at this section, so we're right in the middle of a large watershed. We're not going to do monitoring to see our impact. We know that there are so many other things contributing to this flow that a project right here, as you'll see, is not going to change everything that happens here, but we can reduce the flow that was going into a channel right here. This is all the water from the township property was kind of going under the road here, leading into this swale, which was eroding and heading into the Perkiomen. So I noticed we had Perkiomen Valley High School right here. We had a campus right across the street. So we wanted to tap into them. And that's the situation, the wet area right there. But as we did a site visit, we walked around, we saw there's actually a basin right here. And it was a traditional Amoun basin, so we thought maybe we can have some opportunities to improve this before the water ever gets to here. So here's what the basin looked like. Just traditional Amoun basin. You can see the dandelions in it. They didn't really do anything with it other than mow it. This is what a lot of basins look like. Does anyone else have a basin like this behind their community, maybe at their township building? These are everywhere. We call them bomb craters. And they don't serve much of a purpose other than to collect the water and send it out. So if you look at the outfall structure, which is what this is one of the first things we'll look at when we go to a basin. And notice where the first orifice is, where water is going to exit. Not only is this orifice at the very bottom of the outfall structure, so that when water comes into this basin, it's leaving immediately, meaning there's no time for treatment, and there's nothing but turf grass anyway. But sediment had even accumulated around it, so it's actually even below grade. So water's coming in, and it's shooting right out of this basin. They obviously had some trouble keeping the turf growing, and if you zoomed in, you could see this white powdery substance. There was actually some road salt from the parking lot that was getting into this basin. So our goal was to keep this in the basin and not let it get to the Perkiomen Creek. We also noticed there were swales on the property. This is the before picture. This one, the pipe is even below grade, so you're not getting much flow out of that anyway. Water was sitting in here all the time. No grass could grow. This couldn't be stabilized, so this is a potential erosion issue. This was where the basin outletted into this sort of a swale that led to the bottom of the property. So this is how all the water is draining right to that corner. And this pipe actually came from a separate basin that was taking water from the firehouse. So we couldn't do anything with that basin, but we could handle the water as it got to this corner of the property. So I said, these are all great opportunities. Let's do a large project. Let's fix all these problems at once. And Perkiomen Township said, let's just do a rain garden. let's start small. Let's get the supervisors on board because this is a new idea of doing stormwater management. Let's start with a rain garden. So I said, okay, let's get all the partners on board. Let's get some funding. And we managed to get $2,000 from a mini grant through the Pennsylvania Association of Conservation Districts. And that was for a non-point source pollution education. And they would pay for materials for the rain garden. And we could also host a workshop for educational purposes. And we managed to get a $2,500 grant from the PICO Green Regions Open Space Program, which is administered through Natural Lands Trust. So who in here is from Montgomery County or who works in Montgomery County? Almost everybody. And then everybody else, you also have conservation districts and watershed specialists like me who work in your areas who can help you have access to grant opportunities like this. So I said $4,500, that's pretty good. We might be able to make some kind of a rain garden happen with this amount of money, but it's not a lot. And really, the size of a rain garden that I wanted at that site, which was at least 2,000 square feet, if not more, I said this isn't going to be enough money to do what I would like to do at this site. But we had all of these goals. We were going to protect the creek. We're going to make the area look nicer and be easier to maintain for the township. That really sold them on it. We were going to provide education and outreach for residents, which the township was also on board for because for those of you who understand the MS4, the stormwater permits that townships have, they're responsible for educating the residents about stormwater. So this is kind of a win-win for them. And we also knew that this site was highly visible. It's right along a major roadway. People are driving by it. There's a trailhead parking area for the Perkiomen Trail right across the street. The school kids come over after school to hang out in the pavilion. The firehouse is right there. They have events. The community day is held right there. And the township really wanted to use the property more instead of just having this empty space that was unusable. They wanted to put in a walking trail and really increase their use of the space. And we knew that we had an opportunity to partner with the school district being right across the street. So that was all well and good, but I said I need more money. There's a Schuylkill River Restoration Fund grant round coming up, but I can't just ask for a couple thousand. I gotta ask for more. So that was how I convinced them to not just do a rain garden, but to do the entire site. And it quickly got approved to be what we're calling a treatment train, multiple BMPs in series. So not only were we gonna do this 3,000 now square foot rain garden, we were gonna do the basin upslope. We're gonna naturalize it, retrofit it, make sure that it's treating more stormwater. We're gonna create a vegetated swale that's going to carry the stormwater, the overflow from the basin into the rain garden, and then we're going to fix that pipe at the end and put another swale at the bottom just for a fourth BMP before the water can go under the road and get to the creek. We're going to give it every chance to be treated on site. Luckily for us, the conservation districts can get engineering assistance through the Pennsylvania Association for Conservation Districts. They have engineers on staff. They work out of NRCS offices a lot. So we were able to request engineering assistance from them. I wanted to give a little bit more background on treatment trains. They're essentially just multiple stormwater best management practices in series. When developers are creating post-construction stormwater management plans for their development projects, which get reviewed by the conservation districts. They use these all the time. You have more of a chance of removing as many pollutants as possible. You just give the water extra chances to be treated, to infiltrate, to be used by plants, evapotranspirated. And this is kind of an innovative process that Villanova has been studying on their campus. And you can go visit that. They give tours. They have workshops on that every other year, I think. So here's just a diagram that comes from the Pennsylvania Stormwater Management Stormwater Best Management Practices Manual. That gives you all the math for engineering folks to figure out how you're going to meet your stormwater requirements when you're building a development. So the first problem we ran into before our design phase was we had a utility nightmare. So this is something that I learned through the course of this project that you should all keep in mind before you plan a project. You definitely want to do a one call before you do anything else, because we knew we had the Pico line right here. We knew we had a petroleum line running right through the site on a diagonal. And they'll do flyovers, so if you even try to do anything near their right-of-way, they will be on you. And there's we knew there was a water line here because there's a hydrant, so we needed Aqua to come out and mark their water lines. And of course, we've got the PennDOT right-of-way with the road right here. So we were working with at least 4 utilities, as well as any electrical lines the township may have installed, and trying to map out where everything is, how deep is it, how wide are the right-of-ways, what can we actually do here. So the first problem we ran into was one of our swales would need to cross the petroleum pipeline. We had to find out how deep the petroleum pipeline would be. I got to do something really cool, which is hire a soft dig company, and that's who you see in the picture on the left. They actually dug a small hole with air and a vacuum. And they basically blow the soil away gently and suck it up through the vacuum into their truck to locate where that line is. And that was a neat thing to see. It was $1,800 I hadn't budgeted for, but we had it done. We found out that where our swale needed to cross that line was actually like 8 feet deep. So we had no problem with that, but it was money we had to spend. So that's just something to keep in mind when you're working with petroleum lines. Interstate Energy was actually really great to work with. We had a contact who would come out anytime we needed him. You've just got to do your due diligence and make that work. We also, with the PICO right-of-way, the property lines for some reason got marked incorrectly. So where we thought we were just grazing PICO property, most of our rain garden was actually on PICO property. PICO was partially funding the project, so they were pretty friendly and wanted to work with us. And the property line actually went something like this. So our rain garden was going to be on this side of the petroleum right away. We worked with PICO to put together a lease. That took about 6 months. We've got lawyers involved, insurance people. Mostly the township is handling this as the landowner to get a free, but a lease from PICO to use that property for the lifetime of the rain garden. We go through this whole process, and then they say, oh, we showed our maintenance department, and they say this can't happen. So after all that work, we needed to move the entire rain garden, and we didn't get the lease. The PennDOT right-of-way was pretty simple to figure out. They were able to supply us plans, and we stayed away from that. The water line from Aqua was originally marked incorrectly for our one call, so we had to adjust the design another time because we were going right over the water line, and we needed to make sure we didn't dig too deep because those have to be a certain depth under the frost line. These are all things that I would never have thought of before getting involved into a project like this. You know, I might have thought of the water line. I did not know any of the criteria for petroleum lines, though, what they were made out of, how deep they would have to be. So this is definitely something to think about when you're doing a project. Try and count the utilities. Is this really going to be feasible? And what do we have to do? So I wish we had done all of this before we started to design, because our PACD engineer put in over 200 hours for what he thought was a simple rain garden project because he had to move the location multiple times, fix the lines. We ended up having to do soil tests multiple times because we had to shift the location. And even just shifting it 100 feet, we had a totally different soil type. So web soil survey is really useful, but you got to get out there and do your percolation tests. You've got to do your soil analysis. Is this going to drain? So I wrote property line surprise because of that PICO problem, which is what led us to doing multiple soil tests or redoing soil tests. And when we moved the soil, we were moving upslope, but for whatever reason, we had more saturated soils upslope. And we didn't think that without an underdrain, this rain garden was really going to function like a rain garden. So you'll see that is a component of our design. For those of you who know what an underdrain is, they have a negative connotation because it drains the garden quicker, but I'll show you how we fix that. So luckily, we got an engineer at our office before the design phase finished, and he was able to take over after the PACD engineer had done everything he could for this project. So this is what our final design looked like. You can see our basin over here. Here's our first, it's called out as a channel, our swale here, leading into the rain garden, leading out into this second swale down here, avoiding all utilities, water lines, etc. Our next step while we were creating the stormwater design was coming up with a landscaping design. And I really wanted to get the high school students involved. Usually when people involve students, it's come on out and plant with us and get your hands dirty and get hands-on, and that's great. But I wanted to take it a step further because I knew these kids had some background. We had presented to them on rain gardens multiple times. we thought they could get more involved and take more ownership of the project. And I was hoping that they want to come back and weed it later if they had really if they were really engaged in the process from the start. So we presented to their key club, and we ended up with 8 students who really wanted to help us plan the landscaping for the garden. And we had these meetings where we really brainstormed. I taught them about native plants. I gave them homework, go learn about these native plants. And they filled out a spreadsheet, which is available. You guys can take that with you. That's kind of the product of their work, was this useful tool that I can share with anybody who asks me for plants for a rain garden. And of that list, they were able to pick which plants they thought would be useful for the garden, which ones would be great for wildlife, which ones would help. They were really into monarchs, so you'll see what happened with that. And they wanted the whole back row of the garden to be edible. So this is something I never would have thought to make, and something that having some bright 17, 18-year-olds think about it, they'll come up with ideas that you would never have thought of that are really going to draw people to your garden. So the entire back row is berries, berries, berries. So that was just one neat component they came up with. They also wanted a milkweed patch to be a butterfly way station for monarchs. So this is kind of what the process looked like, trying to pick plants that you'd always have some interest, something would always be blooming. They were really excited about that. One student was really into symmetry, so we made a pretty symmetrical garden. And they came up with this concept of what they would want the finished product to look like. And they used the shape from the engineer's plans to figure out the shape of the garden. And they had this idea of putting in rocks, so it could be used as an outdoor classroom. You could come sit on them. You could kind of walk out into the water when they filled up. That became a liability, so we ended up putting them further outside the garden. But they had all these neat ideas, and that was probably the most rewarding part of this project, was working with those students. And this was their final planting plan that they were able to lead each other in planting the garden with. So there were a few students from the committee who would go around and make sure all the plants were in the right space in the garden according to their plan, and they were very good at that. In the end, they recruited their full club of about 75 students they recruited from to plant the garden, and they have since come back for multiple planting days as well. They were awarded the Schuylkill Scholastic Drinking Water Award from the Partnership for the Delaware Estuary and the EPA. And I found if you want to get some exposure for your project, involving students is the best way to go. People are, everyone cares about the education of our next generation. And here's an example of our project being featured on C-SPAN. Super exciting, from Representative Ryan Costello, just calling out these students for their work on a stormwater project. It was just a good, feel-good moment. And if anyone wants to check it out, we're on YouTube. So, we had a representative from EPA come and present this plaque to the students. And then the following fall, they were awarded the Kids Making a Difference Award by the local Perkiomen Watershed Conservancy. So they felt pretty good about their involvement and realized the impact they made for their community. I asked them, why are you guys doing this? What do you hope to get out of this project? And they said they just wanted to do something nice to give back to their community and improve the water quality. I was like, you don't want recommendations for college? Nope, they didn't even think about that. So it was a feel-good group. And they were all women in the group of 8 students who created the design. So they're all my little landscape architects, and I hope they all go off into scientific fields. So this was construction. The other awesome group of people I got to work with were the Perkiomen Township roads crew guys. And what a fun group to work with. They're joking the whole time. It's really hard to keep them focused on the task, but they did a great job. They learned how to construct a rain garden properly. There are so many contractors out there who don't know how to implement these. They see them on a plan, it's been stamped by the Conservation District, it's ready to be built. The contractor gets out there, he doesn't understand water. He compacts the soil, and they don't infiltrate and they don't work. So you can see the proper method of filling the rain garden soils into the garden. You see the heavy equipment is firmly planted outside the infiltration area, not compacting it. They also learned how to install, this is the permanent turf reinforcement matting. Wherever this is, you see permanent green because people don't install it properly, they don't seed it well enough or water it afterwards. So these guys learned how to install the P300 permanent turf reinforcement matting properly. Because our engineer quit, I got to learn how to lay out for construction. So that was fun for me, putting out the grade stakes. And yeah, this is what it looked like as soon as we were finished with everything seeded and strawed. So construction was going pretty well. It rained pretty much up until the week we did construction, and then it didn't rain for 2 weeks while we were constructing and trying to stabilize afterwards, so we lucked out. And of course, you always want to start downslope and work your way upslope. So we started with the final swale, did the rain garden, and then constructed the swale that would lead into the rain garden. This will be another lesson learned, so I'll get to that. The students came out to plant. We also had our Master Watershed Stewards out to plant. For those of you who don't know the Master Watershed Steward Program, these are trained volunteers through Penn State Extension and the Conservation District and many of our other local partners. And they have volunteer hour requirements and they know what they're doing. So you want them to come out. A lot of them helped me lead this group. So while I was coordinating deliveries, getting supplies, I had Master Watershed Stewards keeping an eye on the students, making sure they're all planting correctly. We even had the township manager come out. There's Cecile Daniel planting a tree in the rain garden. I think that's the only tree that didn't live, but you know, she tried. And then here's a she told me she had a brown thumb. I believe her now. This is the rain garden after we planted, immediately after. The strategy with this was to get enough grant funding to buy as big of plants as possible to fill up the rain garden as quickly as possible. There are other strategies you would use in different situations. Maybe you could use a seed mix and then plant plugs if you have less money and you want low maintenance. We still wanted that gardened look with a mulch bed, but we knew the roads crew guys weren't going to go out there and weed it. So we wanted to fill it up as soon as possible with native plants so that there'd be less space for the weeds to come in. This was a week or so after planting. We had a huge rainstorm. The garden filled up. Very next day, almost all the water is gone. I mentioned that under drain that we did have to place at the bottom of this. What we did to mitigate that, yes, it would drain. It would make sure it would drain within 3 days. But in the riser structure, you see that yellow kind of cage thing that's keeping debris from getting into our overflow pipe, which is the riser pipe. The under drain actually comes into that about 6 inches below the overflow pipe. So if you can imagine, the water is coming in from the under drain, the riser pipe has to fill up a certain amount before it actually overflows. And so that's just an experiment we did, and it seems to be working. That under drain actually holds water. So over the summer, when we were really dry and everyone's plants were dying, it was like a reservoir for our plants, and they were thriving, growing. So it's helped, and it's worked to kind of balance the two. We're holding on to more water than we would if we put it in traditionally, but we're making sure that the garden drains properly and we're not getting complaints. And because we have other BMPs in this series, we're not just relying on that one rain garden to take care of everything. You have a question?
What depth difference was it? Talked about you're holding some water in there between, well, you remember
yes,
what depth it was?
The garden will hold a foot of water.
Okay.
And there are 2 to 3 feet of soil amendments in there. It was extremely clay soil. A lot of places will say, well, you can just add sand. Sure, if you're down in the southeast of Montgomery County, but if you're in that clay shale region, I know Jim's backyard is like this, if you add sand to that, you're gonna make concrete. So you really have to know your soils, know what you're adding. We ended up with a mix that was half to maybe 60% sand, topsoil, and then about 10% leaf compost.
Yeah. So were you trying to make it a biofiltration basin? Is that what your intent was?
Yes, we knew if it was going to infiltrate, it was going to infiltrate very slowly. So we really needed the void space in the soils, and we needed the plants to really be doing that treatment. So this is a site where you're going to have really slow infiltration, but that's where the other BMPs are helping out to make sure we have every chance possible for treatment. And because it is a demonstration site and we're not trying to meet any stormwater regulations, we don't have to treat a certain volume, we were able to put in that under.
I was curious about two other things. Sorry for interrupting you, but before I forget them. One is, I know that you didn't need to do it for detention purposes. You weren't adding any new impervious area.
Mm-hmm.
But did you set your minimum orifice at like the 2-year storm, like a detention basin would?
Yes.
So that you would have some storage until it infiltrated? And the other question I have is, as a lot of it's coming off of parking lots, did you anticipate the future need to excavate some of that biofiltration material to get rid of all the toxics, the oil and the metals and everything that were going to come off the parking lot?
That's a good question. Actually, our basin is hopefully going to take care of most of that. So I'll talk about our forebay and what we did with the basin soon. With the rain garden, yes, they do have design standards that they'll do the stormwater calculations for. 2-year storm is pretty the norm, but this garden was functioning before we built the basin. It was functioning great. Then after we constructed the basin, it's got even less to take care of. So this garden is able to, it's over-designed almost. You know, it could take more. So good questions. So after the garden was installed, we did tours for residents to try and teach them about stormwater management, things they could do on their own property. Maybe not 3,000 square feet of a rain garden, but maybe 200 square feet. One of the highlights of the resident tours was Rob Travers from Villanova, who is a stormwater expert, happens to be a resident of Perkiomen Township. So he strolls up to my workshop, and I'm thinking, oh gosh, he could probably answer these questions even better than I can. He loved it. He thought it was great that his township was doing some good work. So that was a highlight of the tours. We also provided a Con Ed for some Master Gardener trainees. So a lot of Master Gardeners, along with the Master Watershed Stewards from Penn State, are getting more into native plant design, are getting more into stormwater gardens. So that was really cool to have them come out and see what these look like on the ground, and they had great questions for me. I'm hoping they'll also want to come out and use the gardens for their educational tours. So this is available for anybody who wants to use it in the area. We also had our stormwater work group for the Schuylkill Action Network came out and did a tour. The highlight of that tour was they accused me of releasing monarchs from my pockets because as soon as we walked out there, a monarch went flying by and we had 40 caterpillars on the milkweed patch. So you can monitor slow incremental improvements. With habitat, you build it and watch them come. It's really satisfying. So we put in our educational signs. The students helped me create these as well. They said, we really want a separate sign for the milkweed patch. People have to know about milkweed, and they have to stop planting butterfly bush. So I said, okay, we'll draft a sign. We ended up with 2 instead of just the 1. I noted that we built the bottom swale, the rain garden, and then the swale that leads into the rain garden during the first phase of construction. 2 problems with that. The last day of construction was the only day I couldn't be on site to make sure the guys did exactly what I wanted, how I wanted it done. So I wasn't there to watch the straw matting be installed, and I wasn't there to make sure they seeded really heavily. Not that I'm blaming them, but the other problem was the basin. I showed you that orifice at the bottom. All the water that runs into that basin immediately exits, and it's taking on, I believe, 10 acres of drainage. So it's a lot of parking lot. There's an upslope house. There's a lot of water entering that basin. Even in the large storms, the township told me it's never used its emergency overflow. So the water is going in, coming out, right into this swale. And that led to some erosion right after construction. And you can see it didn't really establish very well. We had a couple ruts, and we just weren't satisfied with it. So here's another lesson learned. What we should have done, and what we did the second time, was before we fixed the swale and reconstructed to get that nice parabolic shape, we covered the orifice on the basin. You have a question?
Yeah, doesn't that just totally defeat the whole purpose of the basin, to have it drain immediately? It seems like that would be a bad, or certainly bad design.
Well, I'm glad you think like that.
It used to be pre and post. You used to be able to let out as much water in post development as was leaving the site before development. That's why a lot of basins really never have water in them. Yeah.
Back before even 2010, basins were built for flood control. They were built to municipal ordinances that said you had to reduce the rate of the flow of water that was leaving the site. So these were built to capture flood water, make sure property didn't flood, and to take it to the stream, to get it off site. And now, especially post 2010, all of that does need to be handled on site, and you have stormwater volume, rate, and quality requirements for construction.
It seems like if you get that sort of outflow, you don't even need a basin. It's just flowing.
It's pretty much just bringing everything into one place where you want it, controlling the water on a specific site.
I'm sorry, but they could actually retrofit that by either putting in a PVC elbow to raise it up, say 6 inches, so that at least you had some backflow. Or they could have put in a berm with a stone pervious spillway, which would have allowed the water to back up again, and then slowly exit through the stone and then into that orifice. If they wanted to slow down.
They had lots of options. The problem with, you have to point out these opportunities to the landowners often, and with municipalities, there has to be something driving them to do this. And this was a really forward-thinking township. Cecile Daniel, the township manager, got it. She got it, and she wanted to make it happen. So she was willing to work with us, and they were a great partner. So you'll see what we ended up doing. Here's what our engineers came up with, similar to your elbow idea. This is, we're just calling it a weir box. It's hard to tell how deep it is. It's actually 18 inches. So we had this box constructed. It covers the orifice, but doesn't block it up. It increases the level to which the water has to rise before it will start to spill over the weir into that orifice. So we put that in, and then we fixed the swale where it was draining, and that kept that huge heavy flow of water from tearing up our brand new, yet to be stabilized swale. So that held the water back. That worked great. Now I'll show you pictures. The swale's coming in beautifully. So we constructed the first phase in the spring, and we waited till August to fix the swale, and then into September to do the basin retrofit. We did 3 things here. We installed that weir box to increase the retention of the basin. We created 2 forebays in the basin. We had water entering the basin from 3 points. One was through here. The water was traveling from the front of the building around the parking lot and coming in here. We had all the downspouts connected to a pipe that was discharging on the other side of the basin. And we even had some water coming through the parking lot in between these two buildings and entering at the corner of this fence post. So the goal was to trap all the incoming water into ponding areas called forebays, and these are meant for pre-treatment. So it allows the water to slow down and settle out. Sediment, any phosphorus stuck to that sediment, road grit, heavy metals, gasoline, anything that could be coming off those parking lots, could be the salt, could be trapped in those forebays. So we dug out the interior of the basin and we built the berms with that material, and we made a berm on each side to trap all the incoming water into 2 forebays. You can see how deep we dug down. That's about 3 to 4 feet. And then we replaced all the interior clay soils, broke it up, tilled it, made it nice and fluffy so that water could go right in. And then we took more of that bioretention soil mix we used for our rain garden, and we filled up. We didn't do the whole basin. We just did this interior section here. And this design is working great. Right after construction, you're always going to have some immediate maintenance if you get a heavy storm right after before you're stabilized. So we went out there. I will warn you, we tried to use biodegradable stakes for our matting. Has anybody tried to use those? The ones that are made out of like cornstarch instead of the metal staples that just stay in the ground forever? Well, don't. Until they come up with a better design. The guys were calling them hippie stakes. And I thought they were great until it rained and our matting just floated right up and our seed went away. So don't use the hippie stakes. Stick with the metal ones until they come up with a better design. So we had to come back. We had to fix some erosion. We had to reseed, remat. That's why it looks kind of like a puzzle put together over here. But that did the job. And then about a month later, we had the students come back over, invited them to another planting. We planted 2 areas, the swale leading from the rain garden overflow. This stays wet. So this is, it might be a new BMP. It's like a wetland swale. It's a wet swale. So we planted wetland plants in here. You can see the swamp rose mallow at the end there. That's going to look pretty cool. It gets big pink flowers. And this is right along the roadside. So we wanted to make sure this looked really nice. And then they planted trees and shrubs in the basin, and planted shrubs like buttonbush around the forebay areas, which will have permanent ponding. Some of them will, and then planted that bioretention soil inside the basin. So here's an after picture. What we've noticed with this basin is much more water comes into this forebay than comes into this one. They're both working well. This one holds on to water for a longer period of time. This one stays pretty much dry. So for this forebay, we'll probably plant some wetland plants, just make sure that we don't have nothing but cattails in 5 years. We've got buttonbush surrounding that. We have a few trees to help shade the water, cool the temperature down. We were talking about thermal impacts this morning. That's going to help with that. And even if the water makes its way all the way down to this corner, there's still good pollutant removing wetland plants that are going to be at work. So here's some results from the basin. We had a huge rainstorm back in November, at the end of November, beginning of December. And you could see that middle section totally filled up. And once you've got that 18 inches from that weir box, but you have another couple of feet until you get to the bottom of that rain garden soil mix, or the top of it, I should say. So that's a good 4 feet of water. And I was worried, what's going to happen to that 4 feet of water? Here's when it finally stopped raining, and here's the next day. Gone. Sucked it right up. So I really like this technique. The most expensive part of it was the soil, but that box costs about $900. You could install those if you do your stormwater calcs and make sure that they're appropriately sized. You could retrofit a basin for $900 with a box. But we did do these additional steps. You can see this this 4-bay obviously retains water for longer, works a little differently from this one, but that's what we want to see. So it's working great. At this point, we're almost complete. We have a few things left to do, but the major construction part is over. We just have some maintenance. We've spent a little over $29,000 on this. Put that in perspective, we built 4 BMPs just to get the design. If the engineering costs hadn't been free for us, just to get the design, we wouldn't have been able to afford this with $29,000. So that's pretty incredible, the amount of money that we've saved on this, just by having the township do the construction. They've put in over $20,000 worth of their time and equipment use, and that's awesome. So that's a huge cost savings. Right now we're at $42,000 worth of match, so this looks great to our funders. They're going to be thrilled with this by the time it's done. The value of the project is probably closer to $100,000 to $200,000, depending on what your bids come back at. So this is a huge economical way to install a project like this.
I'm sure that your original engineer determined how much flow was going to come through the facility, because he had to. Did you ever compare the cost to sort of to get a cost value? You know, we treat 50,000 cubic feet of water for 100 grand, or did you guys ever do a comparison cost analysis to see what the cost was of treating the water?
We have not taken it that far. It's a good idea. We did have the stormwater calcs from when that building was built. Luckily, we were able to get those from the township engineer. The building was built in like '96, so they still had all the stormwater calcs for us to work from. So that was easy. We are able to see pre and post the flow changes, and we've done a little bit of analyzing like what the impact of the project is, and but our engineer has put it in kind of like easy to understand terms for the public for us to put on our website. So what we've got so far is around a 30% decrease in the runoff flow, and then we've got that the rain garden is processing 800 gallons of water, and that translates to in a 1-inch storm. So that's what we have so far. We can definitely look at the financials at the end and see.
I mean, I would be curious, just not only as a professional, but as a citizen, to say, like if I built my own treatment facility in my backyard because I do this for a living, and I never costed it, but I was always curious as to, I knew how much it cost me to build because I did it with my own labor. But it would be curious to say your grants totaled so many $1,000s, and you have a flow of so many cubic feet in let's say 100-year storm, and then the cost would come to 13 cents a cubic foot or something, just so people could get an idea of how inexpensive it would actually be to treat.
To get to their pollutant loads per se for like a TMDL. I know that townships are doing that, and they're definitely looking at like tons of sediment removed for this grant amount. I don't like where you're going with that. If there are funders in the room, they're going to be looking at how many dollars are you spending to get this pollutant reduction load, and I'm like, look at the educational value, look at the demonstration value. So yeah, but that's definitely something that should be done, and I know that the townships are having to do that with their stormwater projects. So if I'm right, we've got about 10 minutes. Great. So we have the 2 swales for the rain garden. Our next step is to create the sign for the basin and the swales. That's going to be a little harder to translate to the public. They see garden, that looks pretty, that looks great. Our design idea for the basin is a little different. We're going with more of a savanna style. So we've got that meadow, and we've got a few trees and shrubs that are going to break that meadow up, make it look really nice. and then still have a nice crisp mow line around it so people know that this area is still maintained. We've got a really showy seed mix in there, so there's going to be a lot of pops of color. We want people to like the look of it, not complain about ticks or whatever else that they might be afraid of, but to focus on the pretty colors and the water quality benefits. So that's going to be our next challenge, is creating a sign that explains the basin and the swales to the public as well. One thing to note about our berms, especially for the rain garden, we made our berms wide enough so that, and the slopes low grade enough so that these can be ADA accessible if a walkway were to be put in. So in the future, the township will probably put in a walkway that goes all the way around the property and goes by each of these BMPs and will flow right past the signs. So that was a great tip that our engineer came up with. Said, well, why don't we make it ADA accessible in case? And just from talking to all of our partners, I think that's a great idea for future projects. We have some erosion on one of our basin berms. We wanted the water to take a long circuitous path to get to that center area of the basin. So we put our spillway for that one forebay that ponds a lot, we put it on the opposite side that the water was used to going. Here's the thing about water. Even though the spillway was feet lower than where the water wanted to go, the momentum of that water wanted to go that way. So that's the way it went. It didn't matter that we got the laser level out, we're making sure our elevations are correct. It didn't matter. So that we're going to have to move our spillway to the other side. We'll have to stabilize that with a more permanent matting. We want to do some more plantings in the basin. Now that we know that the basin drains completely, that interior section isn't going to have any standing water, which is awesome. We know what plants we can put in there now, so we'll go back in the spring with the student volunteers, probably some master watershed stewards, and get those plants in just to establish those native plants as quickly as and as densely as possible. We want to get a trash rack that is not flat, that is actually a V shape, so that when the basin, now that it is ponding up and it has potential to use that emergency overflow, we want to make sure that debris is not getting stuck and clogging there. So that'll be an improvement for maintenance. And we still have the money left in the grant, so we'll be able to do that. And then we want to enhance the rain garden plantings. We've had some deer damage. If anyone wants some tips on how to deal with deer, you can talk to me after. We figured out a solution for rain gardens because you can't put fencing up because water's flowing right through. So I can talk to you after. And then we want to come back and weed the garden for the first few seasons to help the township and teach them about maintenance. We did have a workshop with township staff to teach them how to maintain the garden properly. So they know that they can't mow for a couple years. Until they hear otherwise from me, they will not be mowing anything. So I wanted to have some updated shots, so I went out there February 28th and took some photos. This seems a little weird in the middle of February, but we've had that warm weather. It's still nice and green. So here's that erosion that we're going to fix on the one berm. In here, we actually had a cover crop. You know, if you plant a lot of those like ernst seed mixes, you need a companion crop, especially if you're planting in the fall, depending on your time of year. So all we have in there now is that annual. And our perennial showy meadow seed mix will start to pop soon, and I'm really excited to see how that fares. And then we'll add plugs, additional species to that mix with plug plantings. And then over here, we were thinking maybe some pickerel weed, something with a high pollutant removal potential, because this is really where that pollutant load, like you said, all the products from the parking lot, maybe from the maintenance shed, but these guys are pretty good. They're on top of their good housekeeping. You know, anything that gets stuck in here. They do know that they're gonna have to dig this out in maybe 10 to 15 years. And if money is still available in our grant, if we have leftover funds, usually in a forebay like this, they'll put a stake and mark the line at which, you know, when the silt deposits to that line, that's when you got to go back in and dig it out and make the capacity in the forebay again. So we'll probably put one of those in, but it'll probably be a birdhouse instead of just a stick. So maybe we'll do a bluebird box. Yeah, and it should look really nice. All of our trees are doing very well, fighting the deer a little bit. Yeah, everything's going to plan. So here's just an overview. I want to take you from the top of the treatment train to the bottom. So we start with our basin. Here's that before picture. There's a before and after. And then obviously this overflows into the swale. That's what it looks like today, even in winter, so that's pretty good. That also has one of those companion crops, an annual, so that'll die back soon, and we'll start to see the perennials come up. This will look like a lot of grasses, so it'll be grasses, sedges, and rushes in here. It'll be like 3-foot tall grasses going all the way down. They won't be mowing it except for maybe once a year. Here's a before and after of the rain garden, up here to down here. And it is amazing to go back and see, how did we squeeze that in between all those utilities? Here's a before and after. You can see this wet area. What we actually did when we excavated for the garden was we placed a lot of fill behind the berm and raised that area up so they don't have that problem with ponding water anymore. They're able to mow back there. Then this is when the garden fills up. It enters through this riser, and the overflow pipe is somewhere around here. It joins the water from that other basin I mentioned at the firehouse, and fills up this wet swale. And you notice this nice design component of how we recreated like a natural stream channel here. It looks like nice, and that was to get around the ventilation pipe for the petroleum line here. But I think it looks really nice. I think it's a nice design component. So here's just an overview. You can kind of see the basin, into the swale, into the rain garden, into the other swale, how the water kind of zigzags down through the property. So at this point, I'll take any other questions, any additional questions.
How long is that forebay ponded?
How long does it pond for? It keeps about 1 inch long term. The forebay? No. No. It was kind of ponding before. It was kind of ponding before.
I thought it was that drained right out because you had the orifice at the bottom.
There were a couple areas that would just stay wet because over time the grading in the basin changed and sediment had piled up in that orifice.
So they were used to having sustainable water.
Yeah, and I mean it's just more treatment time. We have plants that like the wet, saturated conditions there, and we're going to be planting more plants. The nice thing about that, if residents are concerned about it, they can't really see that side of the basin. It's kind of hidden behind, you know, but I think that's normal to have these natural ponding areas long term. And the one on the other side just completely drains, it has less water running to it. But the fact that we're holding, the longer we hold that water back, the more time the sediment and the silty stuff has to drop out of that, and then it can be used by those plants. I think in the summer, we're gonna see, and we haven't had a summer yet with this basin, we might see that dry up, but I like where it is right now because that means I can plant my pickerel weed, and that'll make me happy, so.
Do you have any concerns about that long-term ponding as far as mosquitoes?
No. If you have the plants and you have the mosquito eaters, you're not going to have a mosquito problem. So that is a concern of complaints from residents about mosquitoes. But I've done a few of these basin projects that have permanent ponding areas, and then they overflow into the infiltration areas. And I've worked for weeks at a time monitoring them, you know, replanting. You know, I'm wading through waist-high plants. I've never been bit by a mosquito in a properly constructed basin. I've never even gotten a tick in one of these newly planted basins. So I'm not concerned. I'm sure residents will be, but you just try to educate them.
The frogs will come.
Yes. I don't have my picture, and there might have been a picture of me during construction, day 2 of constructing the rain garden. I had a frog in my hand. The guys were laughing at me, but
They will come and eat the mosquito larvae.
yeah. So I think our time's up. If anyone wants to hear a funny deer story, you can stay behind and I'll tell it. Thank you, guys.